Okay, thank you. Um, yeah, so let me go back. So IoT has become very important. So some of the students in the past have taken my course on IoT. So for example, Sontu, so he took that course on IoT. He was very active. He did some good stuff. Like that, there may be few other students also who may have taken my previous course on IoT, or even if you have not taken, you may be having some knowledge about IoT. So IoT has become very popular at present, as most of you probably know, and it is also my bread and butter. It is my research area, and so applications of cloud in IoT and the other way have become very, so cloud and IoT have become very technologies which work hand in hand. Okay, so I thought of, so I'm not going to cover IoT in full detail over here, because that is not the purpose of this course. Here actually we are supposed to learn about cloud computing, but I wanted to talk about IoT over here because I'm going to talk about the integration of cloud computing in IoT, right? So this is very important because even some of the projects that you are doing, those projects also, they involve IoT and cloud, right? So you should actually know, what are the important aspects of IoT. So I'm not going to talk about all of IoT because that is not the purpose of this course. There is a separate course for it. If you are interested, take my course next semester. So that is on IoT, and yeah. So but I just wanted to talk about how IoT has become very popular and what are the why cloud computing and IoT basically these have been strongly bonded together. So I'm going to talk about some of these, right? Before I do, I just wanted to tell you, those of you who do not know about what IoT is all about. So IoT is basically Internet of Things, which is basically the internetworking of different physical objects, right? So these physical objects are basically any of the physical objects that you can think of, including the toothbrush that you have used in the morning or the rice cooker that you will be using in the using for lunch, right? So basically anything and everything that you can think of are candidate things in the domain of Internet of Things. Now the question is that why IoT has become very important. IoT has become very important because it can help solve some of the challenging problems that we humans face in our day-to-day lives, right? So that is the reason IoT has become very popular. I'm just touching upon some of the important stuff, but if you are curious to know more about these, feel free to send me an email and I will be able to guide you. I will send you some relevant materials for you to go through to enhance your knowledge on IoT. So I'm just touching upon IoT because this is not something that we intend to do in this course to learn about IoT, but I just wanted to teach you enough so that you can appreciate the use of cloud computing in IoT. So so as you can understand that these physical objects, these are going to be remotely monitored, these are going to be remotely actuated. So these have sensors and actuators which are basically attached to them. These sensors could be any of the sensors that you can think of, whether it is a vibration sensor, whether it is an accelerometer sensor, whether it is temperature sensor, humidity sensor, or anything basically that you can think of. Now these sensors, basically what they do is that they continuously sense whatever they are supposed to sense, right? If it is a vibration sensor, it continuously senses the vibration around wherever it is positioned, and it is going to send the data, the sensed data, continuously for further processing. Okay, so where is this data going to be processed, right? Traditionally it used to be processed in the in a server, but now with the advent of cloud computing, the whole idea is that you dump all your streamed data for further processing at the cloud. So cloud has become very popular because it is there is no upfront infrastructure investment, and one can simply subscribe to cloud services and dump the data for storage and further processing on the cloud. So this is why, IoT, which is extremely data intensive, it needs the processing and storage, and continuously if you are going to stream data, just imagine that over just an interval of, let us say, 1 or 2 days, how much data is going to be produced which has to be stored. So if you have a scalable infrastructure like cloud, so the life becomes easier, because if you need more storage, you can easily get more storage. What you have to do is simply you have to click somewhere in the portal of the cloud service provider, and you will be able to enjoy more more storage or whatever. So like storage, actually there are other things also which are also important for IoT, so including something like fast processing, etc. So fast processing is also important. So cloud can give you all sorts of different processors that would be used for processing the IoT data. Okay, so this is the reason IoT and cloud. IoT is good for sensing, and cloud is good for storage and processing. So if you club sensing, storage and processing together, what you have is a very powerful complex system, a powerful system of systems, a complex system. So this is what IoT cloud is all about. Now uh, you know so in going back to IoT basically uses different types of communication and networking technologies, and these are required because ultimately it's all about connectivity. So connectivity to establish the to collect the sensed data and send it remotely. So this is what is required to be built up, right? So this connectivity will have to be built up. So for that you need these communication and networking technologies, and we are going to talk about these technologies which are going to help take or carry the sensed data from these IoT devices to the remote cloud for further processing. At this juncture, before proceeding further, I just wanted to tell you that there is something which has become very popular, so which is called fog computing. Cloud computing was around, but then fog computing also became very popular. Here in this course we are not talking about fog computing, but then after fog computing, people are nowadays talking about edge computing. So the whole idea is that, can you do some of the processing that you used to originally do at the cloud remotely, can you bring it closer to the source devices from where the data originated, so that you can cut down on the latency, that means the time it takes to send the data, to process the data. So you want to do all of these as much close as possible to the source. Okay, is this clear? So some of you students, you are already working on some IoT based projects, and you are sending your data to the cloud for further storage and processing. So what I am basically referring to. But let us try to understand some of these technologies in a little bit more detail, particularly from a communications perspective. So this is why I basically thought of exposing you to this series of lectures which are going to help you to understand how IoT can help. Now going back, IoT basically senses and sends data, it streams data, and it all depends on the physical event that happens, or the sensor. It all depends on these to know how much of data is going to be produced per unit time, how much of data is going to be produced per unit time. But if you are talking about streams of data, if you are talking about cameras which are going to send multimedia data, so we are talking about typically large volumes of data that will have to be handled appropriately. So that is where something called big data, I do not know how many of you have heard about big data. So big data basically has become very popular. In big data, basically, we are talking about large volumes of data coming at high velocities and so on and so forth. But another thing that is very important and is an important characteristic of big data is that these data are not necessarily structured. So there are structured and unstructured data, large quantity of data that are generated, that will have to be analyzed to get insight into the different types of, let us say, business patterns, if you are talking in the context of a business, right? So big data basically refers to the data which is also which is too fast or complex to process using the usual methods, and so you need some new types of methods for processing these kind of data. So big data basically are characterized, by the way, in case you do not already know, big data are characterized by certain properties. So some people refer to those properties as 3 V's, some people, some definitions refer to these as 7 V's, and so on. So basically these properties are, these V's are volume. Basically the volume means the amount of data that is collected from different sources. So the volume. Then comes the velocity, that means the rate at which the data is being processed or generated and processed. And then the variety basically refers to the different formats of the data and transferring the data across different systems. Like this, actually there are different other properties, other V's, that also characterize big data as per different other literature. So cloud, basically cloud is a centralized system that can be integrated with IoT to deliver and transport the data that are generated from these different IoT sensors. And so you send it over the internet or a separate internet network to different data centers, right? So the different data and the programs, these can be accessed relatively comfortably from the centralized cloud system. And the cloud computing basically offers you a solution which can be economical, and it does not require any on-site infrastructure, storage, processing, and analytics, infrastructure for storage, processing, and analytics. So these are some of these different advantages that cloud can offer to IoT. So there are many commercially available cloud platforms that have explicit support for IoT. For example, Microsoft Azure, that we have covered in the course earlier. So Microsoft Azure, it also has its own IoT solution, right? So so what is the relation, right? So what is the relationship between this IoT, big data, and cloud computing? That basically you get a lot of opportunities through the integration of this big data and cloud computing technologies to produce to store and access data, to process the data, to scale up eventually, and so on. Okay. So now the question is that why did I talk about big data, right? The reason I talked about big data is that most of the advantages of cloud computing, these are going to be quite relevant or quite understandable through the integration of IoT, which generates big data. So this is where big data and cloud, these are strongly linked, and they can be advantageous to each other. Okay, so I think that's more or less what I wanted to tell you about the use of cloud computing for IoT. Achha, couple of different things that are important when you integrate IoT with cloud computing. So one is basically the scalability, right? So scalability for device data. So basically you can scale up using cloud, basically as and when you need horizontally or vertically to meet the needs of the big data. You can basically scale up of the scale up the system, scale up the data that is produced, and its corresponding processing will be eased up. So the cloud basically enables the expansion of IoT, scaling up of IoT, and consequently that big data that is generated from these different devices. So this is what I can think of is the most important tasks. Apart from this, the efficiency in the processing of the data, that also gets enormously enhanced with this integration. Okay. So like this, actually there are different other advantages also that you can think of through the integration of IoT and cloud computing. So let us try to understand some of the networking technologies, some of the communication technologies that are typically used in IoT systems. So as I told you earlier, I'm not going to teach you IoT over here because that is not the purpose, but I just wanted to touch upon some of the important communication protocols that are important for this integration of IoT with cloud computing. So the most important communication protocols in IoT and cloud computing, basically particularly this integration of IoT with cloud computing, the most important protocols are 6LoWPAN, Zigbee, IEEE 802.15.4 standard, following the protocols that follow the IEEE 802.15.4 standard. Then there are other different other different attractive technologies that are there. For example, wireless HART, Z-Wave, ISA 100. ISA 100 is specifically for the industries. NFC, RFID, and Bluetooth. These are some of these different communication protocols that are quite commonly used in IoTs, and they are going to be relevant in the integration of IoT with cloud computing. So what is this IEEE 802.15.4? So this is basically a standard which has become very popular for catering to the requirements of low rate wireless personal area networks. Low rate means low data rate wireless personal area networks. So these are primarily developed for low data rate applications, and these extend yeah, so no, that is different. So primarily these are important for low data rate applications, right? So applications where the data rate are not very high, and also where the reliability of data transfer is a paramount concern, right? So 802.15.4 is a standard that gives specification for two layers. The first one is the physical layer, the second layer is the MAC layer, in addition to the logical link control and the service specific convergent sublayers. And all of these together, they can help communicate the IoT sensors with all upper layers, right? So it operates in the ISM radio band, which I think all of you already know. ISM, what is the full form of ISM? No one? Full form of ISM. That's sad.
Industrial, scientific, and medical standard. Because
Correct. Very good, Sontu. Very good. So this is the ISM radio band, right? So it's free, right? So you can use this ISM band, and in fact, we all use the ISM band for some of it's not a subscribed one; it's a free band, and we can use it for communication. So 802.15.4 basically it uses the ISM radio band for communication, and so basically it offers the specifications for how the physical and MAC layer are going to operate and are going to communicate with the layers above, that means layers 3 through layer 7. So 802.15.4 it utilizes the direct sequence spread spectrum modulation, which I think you must be already aware. So it's a modulation technique, DSS, and there is another modulation technique which is what is the other one? DSS, and other one is what? What about frequency hopping spread spectrum, FHSS? Okay, so high tolerance to noise and interference, and offers link reliability improvement mechanisms. These are actually some of these important features of 802.15.4. So there are a few other specifics that are also there, which I'm not going to talk about explicitly, but you yourselves are urged to go through them individually. Whatever are there in the slides, you should understand them properly, and also you should be able to go beyond, and you can use other protocols as well, right? So basically these are some of these different other specifics which I'm not going to talk about in detail. Okay, so 802.15.4, it has a very low duty cycle. It offers very low duty cycle, and the minimum power level that is defined is minus 3 dBm or 0.5 milliwatt. So under the best conditions, the transmission range can reach up to 1000 meters, that means 1 kilometer. So you can, if all the environmental conditions are perfect, then theoretically basically you should be able to achieve the transmission range of up to about 1 kilometer using IEEE 802.15.4 devices. So the standard transmission range on the other hand is only 10 to 75 meters, again depending on the environmental conditions, right? And the transmission path is mostly line of sight, and there are two topologies that are supported, the basic star topology and the basic peer-to-peer topology. So this is the layered architecture of 802.15.4 on the right hand side, and how it maps to the existing 7 layers of OSI, right? So as you can see over here, all of these layers starting from physical to the network layer, all of these are scoped to be in parallel with the physical layer and the data link layer of IEEE 802 of OSI, physical layer and data link layer of OSI. There are different variants of the standard. So there is the base version, which are basically the A version and the B version. Then for China there is the C version 802.15.4C. For Japan it is D version 802.15.4D. For industrial applications it is E. For active RFID uses it is F, and smart utility networks, that means smart grids, it is G. So I think many of these you would be able to remember because their letters basically start with that particular. So these words basically start with this particular alphabet. Okay. So I'm not going to talk more in detail about 802.15.4 now. I'm just going to leave you for your own reading at this point, and I expect you to pick up some of the relevant literature and go through them for your detailed understanding. So any question? No question?
Hello, sir. Can you hear me?
Sorry, who?
Sir, I'm Nitesh. Sir, so like a small doubt. You were
Yes, Hitesh,
saying
Hitesh.
that the IEEE 80, whatever the name was, it uses
802.15.4.
OSI layer for communication. Like, so does IoT devices does not support TCP protocol?
No, you have to understand, right? So you see, whenever you are talking about IoT, actually it's a long story. So let me just tell you like this, that IEEE. When you are talking about IoT, right? So there are two options that you have. You can use the existing internet to communicate, right? In which case, the backbone of which is based on the TCP/IP, right? Because the internet works on TCP/IP, and then you can either use that, or you can create your own internet work. That is also a possibility, right? So if you have to create everything from scratch as a separate internet work, the options that you have are all different from whatever I have talked with you. Now here, over here what we are talking about is that if one IoT device, okay, wants to, let us say, send something locally, let us say that trying to form a personal area network, right? So if you are trying to do this, you can use some of these protocols, relevant protocols that are there under the standard 802.15.4 standard. You can use these protocols to perform this kind of communication. So with the help of 802.15.4, the attraction is that you can you can have low cost, low energy consumption, and so on, for this communication between these different nodes of this IoT system. Okay, but ultimately, if you are finally sending everything through the TCP/IP, that means the internet, then at that time appropriate levels of handshaking will need to be taking place between these different layers of the let us say 802.15.4, and if you are using, let us say, 802.11, so you need to have appropriate levels of handshaking between the corresponding layers, right? So this interworking will have to happen.
Okay, sir. Okay. Thank you, sir.
we still have some time today. If you have any other question, I don't want to get to the next slides right now because that will be that will take some time. If you have any further questions, you can ask.
Sir, what is basically the difference between 802.11 and 802.15?
These two are different standards, right? So there are several standards which have been proposed, right? There are several standards that have been proposed. Let us say your Ethernet. Okay, so Ethernet is 802 point what? So when you are using your LAN cable, when you are plugging into your laptop or desktop or whatever, so that is basically for the local area network, right? So you are connecting typically to your local area network. So what is that LAN cable, what is it using typically?
Sir, 802.3, I guess.
Very good. So 802.3. Okay, now if you are talking about wireless local area network, right? So for that there are actually several standards that are there. One of the most prominent standards that is relevant is this 802.11, right? So 802.11 has its own different variants, as you probably know, A, B, G, etc. So those can be used to set up a wireless local area network, right? So that is basically the 802.11. 802.15.4 talks about something else. Okay, it's not just about local area network. Here actually you are talking about setting up, let us say, a low cost, low data rate personal area network. Okay, wireless personal area network, WPAN, right, with the help of 802.15.4. Actually within 15.4 there are different other specifications that are also there, but grossly it is at the high level, it is basically talking about uh, setting up these wireless personal area networks, the standards for it. Like this, actually there are other standards also that are also available. There is something called 802.IEEE. So IEEE means, like, IEEE is the one which is the standardization body for that particular standard, right? So there is another one called IEEE 802.15. Acha, Bluetooth is what is Bluetooth? What standard does it follow? I'm sure that you guys are using Bluetooth, right? What does Bluetooth use? No, I'm not going to tell you this. Achha, you tell me. So there are several other standards. There is something called 802.15.6, right? So 802.15.6 basically talks about basically healthcare. Okay, so healthcare related applications, personal area network, wireless personal area network catering to healthcare applications. Okay, so that is 802.15.6. Similarly, 802.16 is there, 802. So many several standards are there. Those of you who are curious to know more about these standards, what I urge you to do is basically search up in the internet. You will be able to get all these IEEE different standards that are available, right? So IEEE is one of the many standardization bodies. So IEEE standards are very important. Like this, actually there are many other standardization bodies who have come up with standards for various things, and the devices have been developed accordingly to cater to the requirements of these different standards. So 802.15.6, I was telling you, 2013 actually they came up with this standard, right? 802. It was proposed in 2013. So in 2014 itself, a couple of my students, they started working on IEEE 802.15.6 standard catering to the requirements of healthcare. And we also came up with a prototype device, because there was no device which was supporting 802.15.6 at that time. So we came up with a prototype device to cater to the requirements of 802.15.6. Actual adapter, actual hardware has been developed to cater to this particular requirement, right? So this is the interesting stuff, how you can have different devices to function by following the standards that are specified as part of different standardization bodies. Okay, so I think I told a lot more than what you asked, but I think it answered your question. What you wanted to know. Did it answer your
Yes,
question
sir.
that you wanted to know? Do you have
Yes,
any further? Do you need any further clarification on this?
no, sir. I'll read up on that.
Okay. Anything else? So I think we will leave you at this point, and let you prepare for your test, not test, sorry, the quiz day after tomorrow. And I hope that and also please make sure that you do the project very seriously, because otherwise you will be vulnerable to lose lot of marks, right? And I don't want unnecessarily, I do not want to penalize anyone. Okay, so please make sure that you take due care of your project. And actually the projects, everyone, whatever you projects you are doing, it's not like rocket science, right? So basically, very simple projects only you guys are doing, which is fine. But what I want you to do is that you should complete the projects, right? Don't leave it incomplete. And in some groups, actually I found last time also that some students are working, others are not working, okay, in the group. That is not desirable. If you have such a case, please let me know confidentially, who has worked, who has not worked. Then I will try to resolve that issue. So it's not like, if all members of the group are all going to get the same marks. If I find that some groups, actually some students have worked harder, they deserve more marks than their peers. Okay, so please let me know if that is the case in your group. Okay. Okay, thank you very much. So we are going to leave now. Thank you, all the best. Bye.